Hello and welcome. In my last video we learnt about the remainder theorem, and that is if a polynomial p of x is divided by a linear divisor, x minus a, then the remainder r is simply equal to the polynomial evaluated at x is equal to a. But let's look at a special case. Let's look at a special case that if r, the remainder, which is equal to the polynomial evaluated at a, and this turns out to be equal to 0, then we can say x minus a is a factor of p of x. And that's pretty much all there is to the factor theorem. It's just a simple variation of the remainder theorem, with the result being 0 and the divisor being a factor. So let's have a look at some examples. Okay, so show that x plus 1 and x plus 2 are factors of 3x to the fourth plus 19x cubed plus 44x squared plus 44x plus 16, and factorize. First of all, it's important to write x plus 1 as equal to x minus negative 1. We definitely need this operator between the x and the constant to be a minus. So then p of negative 1 is equal to 3 times negative 1 to the fourth plus 19 negative 1 cubed plus 44 negative 1 squared plus 44 times negative 1 plus 16, and that's equal to negative 1 to an even power is always turns out to be positive, and negative 1 to an odd power will always be negative. So it's 3 minus 19 plus 44 minus 44 plus 16 is equal to, thank goodness that these 44s will cancel out, so 3 minus 19 is equal to negative 16 plus 16 is equal to 0. So therefore x plus 1 is a factor Okay, let's look at the case of x plus 2. Again, x plus 2 we should write as x is equal to minus negative 2, and again p of negative 2 is equal to 3 negative 2 to the fourths plus 19 times negative 2 cubed plus 44 times negative 2 squared plus 44 times negative 2 plus 16. And this will be a little bit more tedious to work out. So 3 times 2 to the, well, negative 2 to the fourth is going to be 16 plus 19 times negative 2 to the third, it's 19 times negative 8 plus 44 times negative 2 squared, so that's 44 times 4 plus 44 times negative 2, that is negative 88 plus 16. Still working through, so 3 times 16 is 48. 19 times negative 8 is equal to, so 8 times 9 is 72, 8 times 1 is 8 plus 7, that's going to give us negative 152. So plus the 44 times 4, 44 times 4 is 16, and 4 times 4 is 16 again, plus the 1 is going to give us 176 minus 88 plus 16. Alright, let's now see what my mental arithmetic is like. So 48 minus 152 is going to be the same as 152 minus 48 in negated, so it's going to be negative 104 176 minus 88 is going to be 88. And we're left with a plus 16. So negative 104 plus 88 is minus 16. And plus 16 is equal to 0. So therefore, x plus 2 is also a factor. Okay, so since x plus 1 and x plus 2 are both factors of the polynomial, I'm going to multiply them together to get me a quadratic expression. So this should equal x squared plus 3x plus 2, if I was to distribute that out. And I'm going to divide our function, our original polynomial, by this to find the rest of the factors. Alright, with long division of polynomials, I'm always focused on this leading term. And I asked, what do I need to multiply this x squared by in order to get 3x to the fourths? And the answer is 3x squared. And I put it in the same column as the x squared terms. So 3x squared times x squared gives me 3x to the fourths plus 3x squared times 3x will give me 9x cubed plus 3x squared times 2 will give me 6x squared. So I'll write this a bit clearer. And I take the new line away from the terms above it. Okay, so this will cancel out. 19x cubed minus 9x will give me 10x cubed. And 44x squared minus 6x squared gives me positive 38x squared. And I bring down this plus 44x term. So now what do I need to multiply x squared by to get 10x cubed? And the answer is 10x. So 10x squared, 10x times 10x times x squared gives me 10x cubed plus 30x squared plus 20x subtract the new line away from the line above. I'll write that in different colour. Subtract the new line from the line above. Okay, so that will give me 8x squared plus 24x, and bring down this 16 plus 16 term. So 8x squared plus 24x plus 16. Subtract the new line from the line above, and we'll get a remainder of 0. Alright, finally what I'm going to do now is to factorize this quotient, which is a quadratic, into a product of two linear binomials. So 3x squared plus 10x plus 8. I have a video on how to factorize this quadratic, so please have a look at it. I'll include the link in the description below, but for now what I'm going to do is to multiply this coefficient and the constant 8 together to get 24. Alright, and I need factors of 24 that will add up to 10. So the factors of 24 are 1 and 24, and they add up to 25, so that's no good. 2 and 12, which add to 14, so that's no good. 3 and 8, which adds to 11, so that is no good. 4 and 6, which adds to 10, so that's what we're looking for. So we can rewrite 3x squared plus 10x plus 8 as equal to 3x squared plus 6x plus 4x plus 8. And now we can factorize out some terms. So in the first two terms I can factorize out a 3x. I'll write that in a different color, 3x, and I'm left with 3x outside of x plus 2. And in the second set of terms I can factor out a 4, and I'm left with 4 outside of x plus 2. Now I can factorize out the x plus 2, and that will leave me with 3x plus 4 multiplied by x plus 2. Okay, so we have completely factorized our original polynomial. Our original polynomial was 3x to the power of 4 plus 19x cubed plus 44x squared plus 44x plus 16, and we factorized it to x plus 1, x plus 2, x plus 2 again, and 3x plus 4. So we've got 2x plus 2 terms, so we can write that as an x plus 2 squared. So x plus 1, x plus 2 squared times 3x plus 4. So that's the gist of the factor theorem and factorizing polynomials. If you have found this video helpful, please give me a like. If you are currently studying math, please feel free to subscribe to my channel for future videos that may help you on exams or assignments. And as always, please feel free to ask me any question by commenting on any of the videos that you've seen. Thanks for watching, and I hope you've learned something.